Hi, I'm Dinesh. So I'll be explaining the supervised learning model, linear regression supervised learning model that I created. So for this, I used AB daily stock data from S&P 500 company called AAP. So for this, I used open for in this data set. We observed that it has open, high, low, close, and the valid data within the data set. So using this data set, actually volume, name, and date. Using this data set, first I tried to remove any null or not a number values from and empty strings, and identified there were none. And after that, I started working on the feature extraction and scaling. So for this, I actually extracted 10 features with regards to the data that was available within the data set, and such as daily return, true range overclose, high low range overclose, intraday return, previous return, such as that. And once that is done, I went through the feature scaling. For that, I used actually ridge scaler. After that, actually I went through test data splitting. So I went through 80-20 split, where 20% was used to train the data and 80% was used to test the data. And once it is done, I went through the robust scaler, because if you are going with standard scaler, we are going with the median value, but the stock data itself has much outliers. So I wanted to actually work with the median values to remove the outlier impact as much as possible. So I went with the robust scaler, and for this I used actually rich regression. So rich regression over standard regression I used because I was working on multiple data that is not, because if you are going with standard regression, the data point should be independent, but in my data set, they are actually correlated most of the data. So I went with the rich regression because it supports that. So once that is done, I actually found the training set for the to calculate the R2 score and RMS score as well. Once that is done, I found that R2 score actually so R2 score actually is much lower, where for the training it got 0.005, and R2 test was minus 0.05994. So, and for the RMS training dataset as well, we actually identified that the value is much lower, and when we actually check the ridge predicted versus the actual day return, so what we needed to do get was the return of the day using the return of the stock per a particular stock from to a prediction using the ridge regression. But we identified that the variation actually is much lower due to much outliers that we are seeing, and because of that, I tried with actually hubris regressor. So what hubris regressor does is actually it actually introduce coefficient with multiple weights to actually to reduce the impact of the outliers. So once that impact of the outliers were removed, we did the testing again. I did the testing again, and then found out that the Hubert test root mean squared error is also a bit similar to the Rich test. So that means that whatever the the two values that is coming similar, that means the outliers were not the only ones that is impacting the issue with the model's prediction. So since the stock data itself is much more varying, and we are trying to actually test it within a time period, I try to check whether rather than a scalar value, whether the stock is going up or down using the logistics regression. For that, I used the logistics regression actually, and from the logistics regression itself, I found that let me show you. Yeah, from the logistics regression that I found that the test accuracy is 0.5282 and the valence accuracy is 0.5279. So it's actually 0.5 within the range of 0.52. So what the conclusion I came to was that we can't actually predict from a single data set, from such as S&P 500 individual company, a value that is actually whether to check a predicted value from the data set or a correct prediction on the whether the value is going up or down. So that was the that was the lesson that I yeah. Next I'll be explaining on the principal component analysis that I did under supervised learning. So for the principal component analysis, my idea was to actually do the dimensional reduction on all stocks over the 5 years, which related to multiple companies, and identify a small set of deductions actually on the individual stock returns to see how it actually how many components do we actually need to identify how the direction of the particular stock varies, how many actually variables actually, how many features, how many dimensions actually we need to use to identify. So what I did was actually I used NumPy and Pandas and Matplotlib to obviously plot the graphs, and I use standard scaler for the pre-processing. So first I actually loaded all the stocks, all the stock related data from the CSV, and in this one as well we have the date, open, high, low, close, volume, name, the stock related data. So from this what I understood was actually there were 496 stocks and into 525 within 525 days. So what I did was actually create from the 6,000 and 1900 rows, I pivoted to a matrix which is 525 days by 496 stock returns. So with this actually I was able to identify, I was able to actually I was going to actually identify the standardized actually variance. So the first step that I needed to do was use the standard scaler with the mean. With the mean and STD values, so I scale the parameters first, and after that I went through the creating of the covariant matrix. So the covariant matrix actually has the all the covariant matrix is actually 496 by 496 matrix, which related to stock data. So from the covariant matrix, I was able covariance matrix. I was able to identify the the actually the next steps that I need to do is to actually get the icons values from the coordinates matrix to identify the next steps, which is the principal component analysis. So after that, I actually wanted to actually identify how the first principal component actually how it directs. So for that, I actually created the correlation matrix. So for the correlation matrix, actually shows for the first stock columns and stock rows for the first 40 days, how actually the correlation actually happens, and from loading the principal component 1 on the first tagging directions, I was able to identify the heat map, actually how it actually going through each of the steps. And after that I actually went through and I used a scree plot to actually identify for the first 50 principal components how it actually varies with the we say full spectrum, and so what I want to do is actually pick the smallest k, which is retain. For this we used 80 to 90%, 82 within the 80 to 90% percentage to actually keep when we are actually analyzing. We wanted to keep within the 80 to 90% how the PCS are actually calculated to be having a particular value. So when you are looking at the cumulative variance, we can see that it actually bends it actually doesn't reach the 80 to 90% value much, but it actually bends before. So once that is done, I was able to actually check the PC score over the standard time, and I got this plot. And for the PC1, actually we identified that for the it has largest loading on stocks. So what it meant was actually for the what it meant was actually when you are using smaller scale with the cumulative variance greater than 18, we actually got principal components around 103. So with the smaller scale where the variable components was more than or equals to 9%, it was 170. So and the Kaiser, the eigenvalue count, where the max when we actually calculate the Kaiser values, we got 101. So with this as well, we identified that even with the 170 value, to get some correct idea on the variance happens over time, we have to we have to check 170 dimensions within the principal component 1. So rather than 2 or 3, we can't actually do that identification with just 2 or 3. We have to use these 170 values. So still it's a win because it's much less than 496. That was the implementation that I had done.
Hello, I'm going to discuss about the random forest algorithm I have implemented to demonstrate the supervised learning algorithm for our selected data set, the stock price prediction. In here, I'm going through the code base. I have implemented. First I import the required libraries as this, and after that I have added the these two lines for ignore the unrelated warning for get the clear output when notebook executed. And here I added the load data method to load our read our CSV file based on the provided file path, and make the data frame from that file. After that, I have added the print statement whether we can load the data successfully checked. And here is the method I have added to get the feature extraction from the data frame we have get from the file path. And I have extracted the these features from data frame. Before going to extract the features from the data frame, I was cleared the data frame press using the drop na method, that is data frame inbuilt method, to remove the null value contain rows. After remove all the null rows, we are ready to get the features from this data frame. These are the features I have extracted with calculating the data frame: daily change percentage, daily range percentage, sample simple moving average for 10 days, and simple moving average for 50 days, and distance from the 10 period sample moving average, simple moving average, and this is for different simple moving average for 50 days. Then after volume features, then momentum features, and these are the target variable I have extracted. And after that extracting and added these features into our data frame, I have added the print statement to print the df head. Then we can check the data frame after the adding the these generated feature columns. Then in this code base, I have go through the AAP stock data as input file, and then load our data frame call into load data using providing the file path. Then after data frame generated, I have called the engineer features to get the additional feature columns append to the existing data frame. These are the output that we have got after generating the extra features. And here I am going to define the exact features to use to train our random forest algorithm: daily change percentage, daily range percentage, distance simple moving average for 10 days, distant simple moving average for 50 days, volume, and the return 5 days, return 20 days. And these are the xi variables we are getting from the process data method. We are extracting features and target from this generated data frame for the xi variables. Then I have assigning the time series cross series slipped with slip count as the 5. Then I'm created the two arrays, precision scores and accuracy scores. Then we are going to start the training in our random forest. This is the method that going to execute this random classifier. And after that, I have added the logs print statement to print the average accuracy and average precision we have got from this training. These are the output for 5 slips we have assigned here: time series cross validation, and these are the average accuracy for these 5 slip tests. We have got the average accuracy as 49% 95, and average precision 50% 50.47. And after that I am going to generate the plot to view the random forest feature importance to our get result from this code. This shows the importance of each feature we have generated previously. As per this plot, it is clearly mentioned this distance of simple moving average 50 days is more important than other features to get this relevant accuracy and precision output. Hi, I'm Manoj. I'm going to demonstrate unsupervised solution I have implemented for demonstrate the S&P 500 data set AAP stock price prediction. I have implemented this k-means algorithm here for demonstrate this. Here's the implementation of that. First, we initialize the data frame from the this data file. After that, I am extracting the features from this data set and assign the features array. We are going to train this k-means algorithm for feed as the features. I have initialized the volatility, daily return, and inbuilt volume columns as per the features here. And then I have initialized the standard scalar and add this scalar fit transform method to our initialize df features data set. Then I'm going to train this k-means clustering algorithm with our k values is assigning manually here 3 this manually I have added this 3 value for divide these clusters into 3 regions after the train, and random state as 442 and init count is 10. Then after the this train completed, I have added the print statement here for get the result. It will output the clusters as 3 clusters because I have added the k values as 3 here, and the summary of the day count assigned for each clusters, and volatility, volume, and daily return. In the first cluster, we can see the little bit loss here, and after that, I have add the visual implementation to check the check our clusters going to how that going to initialize by the k-means algorithm. This is the plot output here. It will add the three clusters and showing the three colors for each regions in the data set. And yeah, the cluster 0, the purple color is the most common behavior of the stock price prediction, that the teal color one is we can tell as the active days in the stock market, most active days, and the third one, olive green, extreme region. This will happen more rarely in the stock market due to environment going to change. Different news can happen to happen this kind of behavior. Yeah. Hi, I'm Manoj. This is the reinforcement learning algorithm we have implemented for demonstrate S&P 500 data set, AAL stock price prediction. Here we have used the third-party library to change this data frame into environment that agent can play. We use gymnasium and any trading libraries to achieve this functionality. We use here deep Q learning algorithm due to due to Q-learning algorithm cannot use properly with the stock price because there is infinite state regarding the stock price due to its continuity. So we need to migrate from the Q table to neural network here called multi-layer neural network, MLP. That's why we go through the deep Q learning algorithm here. As per the implementation, we have initialized the data frame, then rename the columns. According to that, our third-party library support, inbuilt support, has these feature names. That's why this rename we need to done. Then removing the null rows and print the data frame head for check the data. And here I have assigned the window side initial index and this index as the length of the data frame. Then created the environment from the GIM any trading algorithm for agent to interact with this data.
Hi, I'm Dinesh. So here I have initialized the deep Q network algorithm. So for this I have implemented the learning data 0.001 and the exploration factor where it actually randomly checks the first 10% of the training data. And here I have actually executed the model to learn with the total time steps as 100,000. So what this means is it will pay through 1260 data set about 80 times actually. So it will actually go through 80 times, and once the training is completed, so I have here the observations plotted. So the total profit and the total reward is calculated here as well, and the observation graph that we can actually get from the deep network agent is as this. So we can see how the trading results actually plotted correctly. So that's all. Yeah, thank you.